Welcome to VLearn. This is session number 7 of RDBMS on relational algebra. In this session, we are going to cover topic additional operations, set intersection, natural join, division, assignment, extend relational algebra operation, generalized projection, outer join, and aggregate function. First, start with the additional operation. There are some more are here in the relational algebra that we in the last session studied selection and projection, union, intersection, differentiation. Now some more are additional operation that's shown here. That we define additional operation that do not add any power here to relational algebra, but that simplify common queries like set intersection, natural join, division, and assignment here. Here the set intersection operation that is denoted by this intersection symbol, and in the algebra format we can define this in the relation intersection and the table that belongs to the R, a row that belongs to relation R, and the row that belongs to the S table, and assume that RS have the same arity and attribute of RS are compatible. So that's why through which we can extract the intersection over the relation. This is the example that consider here the two relation R and S that contain the value of alpha and beta. The B column that contain the corresponding value of alpha 1, alpha 2 and beta 1, and the S table that contain the corresponding value of alpha 2 and beta 3. Again the common intersection operation are over here, that alpha and the beta 2 that show that is the common value that extracted from the both table. You can see is only alpha 2 value that is common in both the table. Next is here the natural join operation. That join symbol that can be used like this one that show the join operation here. Then R and S is again consider a relation. Over this we can apply the join, and RS is here the join operation is relation on the schema, and R that union combine the obtain as follows, like consider each pair of tuple from R and S, and it take R the R and S that have same value of each of attribute in the R and in intersection that we say set of difference of S and as a tuple T to the result, where the result will be the T has the same value of TR on R and T the same value of TS on S. Consider here the example R relation ABCD and set EBD. The result of schema will be A, B, C, D and E. The common value should be avoid here to be B, that is be repeated again here. And R is to be defined like this, the column joined over the relation RA, RB, RC, RD and SE, and the over selected query are applied here to particular condition and operation and or operation to be applied here. Over the Cartesian products also be applied here. So multiple conditions we apply over this query. This is the diagram simplest that represent the join over the two table, that R and S over the natural join that combine the table simply A, B, C, D column, A, B, C, D the same here, and B is again repeated over the column and D are different. So the combined form of the table that show the column A, B, C, D and E. So the result is shown as here, join operation applied for the relation R and S, and result is here the combination of the column and the repeated are the removed here. And the natural join again shown here to be another example. Consider relation R1 and S1. This is the value contained in the R1 and this R and the S1. If we join the operation that we get, again see the first the column as ID the same here, the same is again in the column in the S1 and R1. This S name is used here, and the rating and then age, the all column are the S1 are included till here, and the remaining are of R1 that is BID and day are the taken again the next one. Now the join operation you can see here, the according to the relation R1 are the join to be applied here, but not according to the S1, because here the value of the 1 is the 31 that is not matched in the R1 relation, so it is to be excluded here, and the join those value are the same in R1 as well as S1, and the join is shown in this in front of you, this table. Next is we use the division operation. Here the division operation that we used in the division, that division symbol, and this division that denote divide, that is suited to query that include the paras or all. Suppose we want to find all the customer who have an account at all branches located in the, an example you can take here, branches in anything you can take according to the all condition. And this is in front of you that show the suited the query that include paras of for all, and R and S the relation on the schema R and S respectively that shown here. R that this contain column and the S contain this column. So the result of R division S is a relation on schema. So it show the like this, the result of R hyphen S letter we already applied like this here. So division show definition like this, all taken on the row, and select query are applied here, the projection over here, and or using this condition that extract their division operation. Let's see this example. In this example here a relation R is taken S and S is taken one more relation, and here the column is only P and here is the A and B, and you see the result 1 and 2 in the S table. So correspondingly only 1 and 2 the values should match. 1 is corresponding to alpha and 2 is you can see here of the beta, but not to be repeated taken here. 1 is to consider from the here alpha and 2 is then considered the beta value. So the result is shown here according to division operation. Next more example is here the relation R and S, and the S value contain here A and B and the E is the 1 1. So correspondingly it take out the division over this column, alpha value that all A having the value of 1 and the gamma value that all have the value of A and as well as 1 of E. That's it, extract that result of this in the short and division. This was the example of division operation, that division term in the basic algebra at which R and S to be relation apply here, and S should be belong to R. That can be defined like this in front of you. And to see why we use R hyphen S dot S, that is simply record attribute of R, and this is the denote that give the those tuple T that is not in here and such as some tuple that belongs U to S and that is not in the relation R. Next is the assignment operation. The assignment operation that provide a convenient way to express complex query. Right here the write query as a sequential program consisting of a series of assignment that followed by expression whose value is displayed as a result of query. That assignment that is denoted by like this, like कुछ वैल्यू हम किसी और वेरिएबल में असाइन करते हैं तो दैट गोज लाइक दिस असाइनमेंट. Example you take here, the result come from this division that moves in some variable. So we denote it like this. Here the temp1 is the variable that take out the result that taken out from this query, and temp2 another result that take out from this query, and finally the result made by these two result. That means from the different query we get different result, and combination of this result we get the another one. So that we can finally good achieve by this assignment operation. Next is there are some extended relational algebra operation that are generalized projection, outer join and aggregate functions. In the generalized projection that extends the projection operation by allowing arithmetic function to be used over the projection list. Like this is that extract column by this, but we are applying over some function also over the column. That is very helpful to do the work over the database. So E is an relational algebra expression here, and therefore the function, arithmetic function that we are applying on the column, and the credit information that we can get, like a relation, consider example credit information over the customer name, limit and credit balance, that find out how much more each person can be spent here. So consider this is a select projection operation apply here to extract the column this customer name, limit, credit balance over the table credit information. There are some aggregate function that we can use and the operation. Aggregate function that collect of the values and return a single value as a result. Like their average, minimum, maximum, sum, count. These are the value through which we can easily extract the data over the and the function that we can apply over the various column. An aggregate operation is a relation algebra that shown in front of you this slide, that how can we can represent here over the G the function apply over the column, and G1 G2 list of attribute of each group, and the Fi is the aggregate function and AI is the attribute name. This is the next example taken here, aggregate operation. The relation R and the columns shown here, and the sum operation is applied over the column C, that show directly function apply over the C column and show that its result sum 27. Next is the aggregate operation. One more example that shown here, this column, the table taken here, the account branch name, account number and the balance, and again aggregation sum is applied on the balance, that show the result of the parish branch, baritone and the redwood, that show the sum easily. So like this we can apply some function on the column also, that helps very helpful. Now the aggregate function, that result of aggregate does not have the name, that can use rename operation to give it a name. For convenience we permit renaming as a part of aggregate function. This is the example that we already discussed in the last slide. And the next is outer join. That is an extension of the join operation that avoid loss of information and computes the join and add tuples from one relation that does not match tuple with the other relation. In this way some null values are also come as fastly, so we need to be very lessly to use of the null, that is very efficient. If we use null, avoid the null value, that we can easily extract the data. So null signify that is the value unknown, that does not exist. All comparison involving null are the roughly speaking this false definition. This is the outer join example taken here. In this outer join, this is the loan table and this is the borrower table taken here. Like in the next slide we see the how we join apply here, but let's see here. Over this two table was last slide, relation loan and borrower. In the loan we take here loan number, branch name, amount, and the borrower we take the customer name and the loan number. Now the result of the join is here, over the loan and borrower show the loan number, branch name, amount and customer name. And the left join, there the one is the difference of the left join, it consider table left one and take all the correspondingly left and right not be considered here first. In the left, this is the relation loan is the left and this is the right one. So value are taken as according to the left table. So you see here, there the last value L260 is the not match here the loan number. There is the 155. So there the null value come in the left table join. Let's see again. There is the value is of their left according to left. This value is not matched, so it's shown here null. Similarly in the right join, according now we consider right table, all the value that not matched to the left will be remain null here. And the outer join that shown the combination both left and right, here the all value of left as well as come here and the right also. The result of left was this one and the last of the above right one was the result null value here. So this outer join combine both for left and right as well. This is the exercise that you can try it by yourself. Explain the aggregate function with example. And the next is explain the operation of modification the database. This is all about of today's session. We are now winding up here. Thank you so much. Happy learning. We learn.